Okay, good morning, everybody. It is Friday the 13th, 2018, live presentation day. Have you guys even seen Friday the 13th? No. Any of them?
Which?
No, sorry. I didn't even know it was Friday.
The original is a classic. You didn't know? I didn't know. The original is a classic. Not very good. All right, so one thing to remind you guys of is that it is Undergraduate Research Day. All right. It is Undergraduate Research Day next week. Wednesday, April 18th, 9 a.m. to 2 p.m. Stop by and see all of the presentations. Earle has presented at this thing. Rob has presented at this thing, and now Matt will be presenting at this thing. Got a lot to live up to last year. Rob became the face of URAD. Earle has similarly been the face of URAD. So good luck. Actually, we should talk a little bit about your presentation, but we'll do that during your talk. Sadly, the bottom is cut off in the video. I don't think I can fix that at this point. So this was the text that we sent. I guess they're looking for people that were to like put. They usually do like a scrolling kind of a thing where they'll have pictures of mentors and the students, and then they'll have some text. So they asked me for some text. I don't know if I got them the text in time, but this is what I sent them. So hopefully there aren't any spelling mistakes. I think I kind of banged that out at 11 at night or something. I tried to check. Somebody will proofread it. Okay, big event this week is we finally got a full working model of the laser pointer based like map labeler audio system. Pretty exciting. After many weeks of kind of working on the components, it is done. I wanted to use this time just to explain a little bit about how this stuff works. Basically, what I want to do is talk a little bit about how the image registration works. So the idea is we're getting a camera image that's looking at a map object, and then how do we georeference that on the fly, essentially, and pull those coordinates up. So it ends up working something like this. So if we basically got image space, so pixels to the right and pixels down, you have to be a little bit careful about the notation because latitude and longitude are sort of like y, x. So you have to be very careful about that. But a lot of times arrays are referenced in row column notation, which is also y, x. So you have to be very, very careful when you're coding this stuff up to make sure that your x's and your y's aren't crossed, and that happened to me probably 3 times as I was coding this. You kind of learn to develop a sense of when that's happening, but it's something that is you just got to always be watching. The idea here is we're going to do a rigid transformation. Now, there's another kind of transformation called a perspective transformation that we're going to actually probably need to do as well to be perfectly accurate, but I think that this is probably going to work okay. So we're going to basically do what's called a rigid transformation. So we can rotate it, we can translate it, and we can scale it. And that's it. Those are the only 3 things that we're able to do with this particular kind of transformation. That should work okay because that works pretty well for translating between one essentially rectangular coordinate system to another, which is essentially what we're doing here. I'll show you an example of why we might need a little bit of a perspective transformation, but so far so good. There are many, many ways to do this. So OpenCV actually has a point-based system where you specify a list of 3 points and then another 3 points. If you think about it, that's all that it takes to be able to do that mapping. So you guys that have done georeferencing in ARC, you can specify a lot of points, but essentially 3 is really all it takes. And I think actually you can get away with 2 in some cases, but
3 it starts giving you the error.
Yeah. So because I think when I was showing Jennifer, I was using 2 because I was digitizing the scale bar. But anyway, 3 are required for the OpenCV affine method. there is so for the map-based stuff, so that's computer vision, right? OpenCV. The map-based stuff has its own ability to do it. So rasterio is what we use to process raster images in Python. That can do it. There's a specific little sub-package called affine that you can get that's super tiny. It can also do it. And in fact, rasterio uses affine. So all you need is affine. My code uses rasterio. I'll probably pare that down so it's using the least. Yeah, ideally you want to use the least requirements package to do what you need to do. So I'll probably fix that. But the last one though is you can use least squares. So this is actually a better way of doing it if you've got any error kind of inherent in the system. So with least squares, you can actually specify any number of coordinates. I'm hoping that by doing 4 coordinates in least squares, I'm sort of simultaneously solving the warp problem. So that's why I'm doing that, but I'm essentially generating an affine matrix. It's probably not perfect, but it seems to be close enough. This is an example of how so while I was prototyping it, what I ended up doing, I'll wait for this to run.
Davis Hall.
All right, I'll pause it there. What I ended up doing was capturing a screenshot of Google Earth. So I was away, I didn't have access to a camera. I wanted to share this as an example of prototyping. So if I don't have access to a camera or a physical thing, how can I solve this problem? Well, there's really no difference between operating on this as a screenshot and operating it on as a still frame from the camera, right? So it was pretty easy to just snag something from Google Earth. Nothing, this is just an image. I could have drawn this on a piece of paper and it would have worked just as well, which would be kind of fun exercise. In fact, for those of you who are interested, essentially when they do, we haven't done a lot of work on like spatial cognition or cognitive maps, but when people do things like make sketch maps and they're trying to figure out what people know and how they know it, they'll make a sketch map, and the way that you test, one way that you test their spatial knowledge is you can georeference essentially match point to point, get the error statistics that are associated with these kinds of least squares approaches, and use that to sort of quantify how good their sketch maps are. So it's pretty sweet. You're basically measuring the distortion in the image, so it works exactly the same. In this case, this was just sort of a test. I've got a description here. I'm going to leave that alone because this was sort of early work that I did over the weekend, and then now that I've got the full thing coded, we'll just talk about that.
Chick Evans Field House.
So there I'm just kind of clicking around. I did have to, because I couldn't simulate the laser pointer, I also tied in a mouse event listener, which ended up being handy for another thing later.
Yep.
Okay, I think I talked about this text-to-speech engine last time. So this is a little bit of what the code looks like. It's too bad, I guess that little matrix thing at the bottom is going to get cut off in the video, but it'll be in the PowerPoint for anyone listening that's interested. This is essentially what the program looks like. So the top is a series of a bunch of information that's being passed into these variables at left. So Northern Illinois University is just sort of the title of the map. 4326 is the EPSG code for WGS84, so that's telling us that we're using latitude and longitude to reference. And then I've got the latitude and longitude referenced in top, left, bottom, and right. So 41 and change, negative 88, 41 and a little bit less, and then the right-hand side. What I'm doing in the next line is I'm basically saying where in that image do those corners correspond to. So this is the upper left corner, upper right corner, lower left corner, lower right corner. And again in YX format, so row, column. Trying to note that in here so that it's pretty obvious. These are my primary coordinates, and then so these are my secondary coordinates. So these are my image-based coordinates. Where in the image is my map are my map pointers. Where in real space are my map pointers. Does that make sense?
I have a quick question.
Yeah.
So for the primary, did you use how did you determine those numbers to put in there? Like, was that just...
Measured it from the image that I had. So when I set it up, I measured it once. I'll show you how to do it because that's not required. It was just sort of a convenient thing as I'm turning it on and turning it off. I don't have to remeasure it each time. So
And then
That
so-
shouldn't be hard-coded.
So then, how does it get it otherwise? Is that
I'll show you. There's
Okay.
I've got a routine set up to do that.
Okay.
This part here, to get the, so to do the least squares, the padding and the unpadding essentially just increase the coordinate system. So if you think about how this is working, I've got x coordinates and y coordinates, but you can do a least squares solution in n dimensions. So to get all of the parameters that I want to be the rotation, this is strange, I don't know, it's more upper level stuff, but you've got to pad this out so that it's essentially like I'm giving it a third dimension. I'm just telling it that the third dimension is 0. So a bunch of zeros. So now it's latitude, longitude, and elevation, but the elevation is 0. Image spaces, row, column, 0. It's just necessary for the math to work out right. This is so the next line down here is the least squares. So I'm using NumPy to do a least squares. So this is linear algebra, a least squares solution. All I do is give it the primary and the secondary coordinate system. So these are my input coordinates, the image coordinates. These are my export, or my secondary, the latitude, longitude. And then I'm just pulling out, this function actually returns back a number of items. So all I care about is the transformation matrix, which is the first thing that it returns. So I just throw away all the other stuff that gets returned. And then all I do to make the math work out right, I trim off, I basically am passing this into Rasterios affine. So this is a transformation matrix that would totally work. To do some of the stuff that I need to do, it's a little bit more convenient to pass it into a Rasterio affine method. So I do that, I wouldn't have to do that. So as an example over here, these are the primary image coordinates, these are the secondary image, these are the secondary geographic coordinates. This is the matrix that you get back. Where I'm doing T, I'm essentially carving out this 0, 0, 1, those aren't significant parameters, those don't matter. I'm getting back this affine matrix, and then this is cut off from the image that's being recorded. But I'm passing in 7792, so a pair of image coordinates. I'm multiplying that by the matrix T, the transformation matrix, and I'm getting back my map coordinates. So that's the cool part, is once you get the transformation matrix, all it is multiply where you're coming from, right? Image coordinates to that, and you get back that. Right? So if you think about it, that's the meat of exactly what we need to do. We need to track where the laser pointer was, pull the image coordinates, and then get so that's it. It's super easy. So this is one little trick of linear algebra that comes in handy all the time for map processing. I don't really know how I mean, I've done linear algebra a long time ago. I'm not particularly well versed on it. But you learn to kind of take what you can. So it's a little bit of a black box to me, but works anyway.
Quick question on your code back there.
Yeah.
That last with the stereo affine, you have it ravel, so that's putting it back to but that's an open bracket. How does that determine the grid on that?
Yeah. So so essentially this part a dot t, the dot t is transpose.
Yeah.
So this. If you can see the matrix A, what I'm doing is I'm essentially flipping it. Rows become columns and columns become rows, right? So it's kind of here to there. And then I'm trimming off, so imagine it's here to there. I'm trimming off this while I do it. So that's the up to row 2, right? So I'm getting 1 and 2. In Python, it doesn't include the last thing. It's kind of a weird Python-y syntax thing. So I'm really just getting rows 1 and 2. All the columns. Ravel just means I'm taking an array that's 2-dimensional and making it 1-dimensional. That's only necessary because Rasterio.affine needs 6 parameters. It won't take a matrix. It needs the numbers individually. So this piece here, which we didn't ever really talk about in the Python class, this star, is essentially converting it from an array to 6 separate parameters, really tuples. So this star is converting it from a list to tuples.
Okay.
So it's a little dense, but
I don't know if it's I played with the ravel quite a few times. So
Ravel is great. Yeah, Ravel comes in handy for a number of things. So that's anytime you want to take a two-dimensional array and turn it into a one-dimensional array, it just takes these piecewise. So it would go down the list column-wise and do this one, then that 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 one. But because I transposed it, it goes the other way. 1, 2, 3, 4, 5, 6, which is exactly what I find. Why I can't pass the matrix, I don't know. Someday I will. Okay, so here's the structure of the program. I'll demo it for you guys. Essentially, I've got to import the libraries that I need. So I need the computer vision library. I need GeoPy to handle the nominatum request to do the geocoding, reverse geocoding. I need PyTTSX3, which is the text-to-speech engine, which, by the way, note to self, I saw reference to the Google text-to-speech engine, which can not only do it, but it can do it in other languages as well, all just by specifying. You don't need to write the Italian, you just need to say this in Italian. It's pretty sweet. So you need internet access to make that work, but you need internet access for the reverse geocode anyway, so it doesn't really matter.
Universal translator is here.
Totally. Somebody remind me to make a note of that at the end. I hope I can still track that down, but yeah, super awesome. And then fine. Next part here, I need to initialize the text-to-speech engine and the nominatum geocoder. This is just one line for each, saying boot up an engine and then make a connection to nominatum. I need to establish the primary and secondary geographic coordinates. So where is the map in the image from the camera? Where is the map in real space? At the moment, both of those are hard-coded in, but I've got a method to do them, to find them, not to find, but to specify the map corners. The reason is because even when I walked in this morning, the map had gotten moved. So you can't guarantee that the map is going to be in the same spot every time. So you really, really need to be able to adjust where's the map in that image. Item A is going to be supported by a QR code. So there's going to be a QR code on the bottom of the map. You can then scan in the camera. So that's how it's going to pull the geographic coordinates in the future. That's super easy to make the you could already make the QR code, right? And you just put that into something online and it will spit it out. What we don't have is the reader. So we need to add the reader in. There's some Python tools to do that. But that's kind of a low priority. Is we don't have too many maps that we're working with. We can afford to hard code a couple for now and make that the last thing that we do. What is important is where is the map in real space. Right now I've got kind of a manual thing where you've got to kind of mouse click and specify the corners. It only takes 10 seconds, but it would still be nice if this were an automatic process, which I think can happen. I've got a link for how to do that, so if anybody is interested in taking that on, they can. Okay, so the main loop works something like this. You get the image from the camera, right? You're cycling in images 30 times a second or whatever. You've got to flip it. So if you think about the way the camera is oriented that way, and I think probably most of the time when we build a mounting system, it's the wrong way around. So you want north to be up for the user, but the camera is the other way. So you've got to flip the image around. You've got to find the laser pointer in the frame. If the laser pointer is there and it's new, right? Because if you think about it, it's sampling 30 times a second. So if the laser was there in the last frame, don't send a new, like you don't want it to say library, you want it to say just library, right? So one time until it's done. So you have to undo the laser to get a new, so you can't like, just kind of like, we could change that if we wanted to, but I don't think we want to. Although it would be pretty neat, you could theoretically do like, you could paint a shape, right? So you could say like, if you wanted a line, right? If you had a road, you could like paint the road. Maybe it could extract the linear feature and then send that linear request. Ideas for the future, right? But I think that would be a pretty sweet way to do it.
That can also be your path navigation.
Yeah.
Point to point.
Let's, yeah, we'll come back to that. I think that is probably a really, really good idea. Better than the other idea. Okay, sweet. Well, we have lab meetings. All right. Okay, so if the laser pointer, blah, blah, blah. I got it set so the mouse click could work. So while I was developing it, while I was out, the mouse click still works. So those work just as well, which is nice with prototyping. So we pull the laser key points. So Matt has worked on this portion. We just pull the first item on the list. If there are more than, right now, if there's more than one laser key point, so sometimes there are false positives, we could be getting a bit of a problem. So we should have some enhanced error checking there. But so far it works pretty well. The latitude and longitude, it's pulling out of the points. Notice that I had to reverse these. So because we've got this referenced in row column format, I couldn't just pass it item.point. I have to pull out the first one and then pull out the second one, or I would have to reverse it or whatever. But anyway, it's just the same format as we saw before. The image coordinates multiplied by the transformation matrix yield our latitude, longitude. We pipe that into a function that I wrote called what's here, which is amazingly short. I get back a thing to say, so a string. I pipe that string into the engine, and then we're done. So it works out pretty smoothly. It also looks for keyed commands, so if I hit a 1 or if I hit escape or if I hit whatever, those make certain things happen with the keyboard. Obviously, ideally, we'd like this to be sort of like speech activated, but in the meantime, for prototyping, it's okay. And then we annotate and display the image, so to get visual feedback for us as we're developing, like right now, I'll draw that blue circle wherever the laser is so that you can see it. All right, we'll run this and then we'll do it live. You guys have all seen this. Maybe Sammy hasn't
Parking
seen
garage.
this. So again,
Home student center.
I like to make these for posterity, right? Like, 'cause we're going to do a live demo, but now this is encoded in the,
Chick Evans Field House.
but it works super well.
Rev Hall. Disabled Hall.
So one of the beauty of this technique is essentially all we need to do, so we've got this big tile out here,
Parking
right?
garage.
We only have to reference one frame correctly. And then as we put everything else on there, it's automatically correct, right? As long as your interior is correct without error, we can add things on. And ideally, we're going to get to the point where you just, you know, if you want another tile, you could literally just scan it and put it in and start working with it. So I think that is going to work out really nicely. So yeah, I think one of my goals for this week is to get this working with that map so that we've got a giant, I think what we'll do is we'll make a board like that with these once we're satisfied with the time. We'll talk about that in a minute. Okay, I'm going to shift this over a bit, so we're probably not going to catch too much of the demo, but we can catch what we catch. All right, let's hit the lights. The laser pointer recognition right now needs a little bit of adjustment. I think what we really need to do is dial that intensity threshold value based on the overall lightness. So if it's bright out, that threshold is going to have to be different than if it's dark out. But for now, it works better when it's dark. All right, so I got this thing booted up. Hopefully it's still in operation. We've got our image here. I'll let all of you guys do this. But the mouse click still works, so you can sort of see where stuff is. So there's the parking garage. But obviously this is the fun part.
Parking garage. Founders Memorial Library. Chick Evans Field House.
So you can see the blue light, which is the annotation.
Uptown Hall. Home student center.
Feel free to see me. Just try not to bump the map. Well, I guess I should show you how we do the registration. So as you're looking at this, it's interesting. You can see some reflections off of this. So we can use that visual thing to sort of diagnose what's going on. I think so we're getting that secondary signature over there on the right. I don't know what's causing that.
Founders Memorial Library.
It's actually doing pretty well for. Try not to, make sure that if your hand is over the point, it won't see it.
Neptune North Hall. Neptune Central Hall.
Right.
Chick Evans Field House.
So yeah, maybe you haven't even had a chance to play with this live yet, right?
Parking garage.
So it doesn't hurt anything to have a second hand in there. You don't have to be far away. should start it. It just takes a little bit of time because it's doing all this stuff live. So the instant it sees the laser, it starts to make that nominatum request. It takes a little bit of time for that to go out to get the information back.
Looking for the new.
It's looking for the new signals. So if you do, for instance, this.
Parking garage.
Right, so there's the command, but it's not going to keep going. And if I move it around,
Optimizing center.
it probably lost the. What happened was it lost. It thought it didn't see the laser, right? So as I move it, watch what happens on the screen, right? Here's my blue dot. You'll see the blue dot go away. There it is again. So anytime that blue dot goes away, that's where it's lost the signal, and that's where we need to improve the laser recognition.
We're actually getting the reflection off the tile back into the camera.
Into the lens, right?
Yeah. I've heard
Too,
reflections.
Parking lot 21.
too bright.
Mollies.
See, to me, this is the cool part, right? So the difference between OSM and this is that, this is derived from photogrammetric data. In fact, this one is actually LiDAR data. But ideally, it's derived from photogrammetry, right, that you have just taken that is as honest and real a representation as exists. And so everything that's in there, it's going to talk to OSM, and as long as OSM is updated, but you've got full control over that, right? Like, if there's something that's not in there, right, just add it, right? So stuff like Molly's or McDonald's or like all of these little features are, I think, super cool part of this. Things. You thought Lagoon. I haven't done that.
That's what I was trying to do.
Did it go? So yeah, all kinds of stuff in here that. But yeah, I think figuring out a way to do. Well, we can talk about this in a second, but figuring out a way to support different types of geo information so that you can query buildings somehow differently than you query routes, which is, I think, a bit of a limitation. This is all sort of point-based. All right, should we get back to? All right. Oh, let me show you how to do the referencing. So, if you messed up the map, right? The map's gone away, it's gone back, and it's crooked. We can still make that work. We just need to reference each thing. So, I've got the keys. It's doing this key listener, right? So it's listening for certain keys. So 1 says I'm going to specify the upper left corner. 2 is I'm going to specify the upper right corner. 3 is the lower left. 4 is the lower right. And then I think it recomputes the transformation matrix automatically, but T will force it to recompute it. So if everything went smoothly, this should still work.
Founders Memorial Library.
Right. So it's actually pretty easy to re-reference an image after it's been run.
Oh, we don't have time.
There's no 601.
Oh, there's not? No, is he gone?
He's at AAG.
Sweet. All right.
I haven't looked in the photo.
Oh, okay. We'll let Sammy go next then. All right. So,
Parking garage.
we don't want to see that again. Okay, so what do we have left to do? 1, we need to implement a QR code reader for the georeferencing information. So that's not done. I've got a link here. Pretty textbook. It shouldn't really be all that hard, but see the examples. Essentially, what you're gonna have to do is find the QR code, warp it back, and then read it, and then pull the information out. So I'm not saying it's easy, but it's well-established technology at this point. There's nothing too crazy about that. We need to automatically detect the edges of the map for georeferencing. I've got a couple of links for this as well. So there's no reason why it can't automatically pull those corners out and not need the user to reference that. I think for a demo, it's nice to still be able to kind of force it if we want to. Automatic stuff is prone to errors. Probably what we'll want to do is have a key that says launch an automatic recognition, be done with it, and don't, if we were always trying to find it, that would be as if the map is moving around all the time, and I think we don't want to do that. We want to allow it to only read specific kinds of OSM data. That's actually pretty easy. We can put that into the request. When we were doing the overpass stuff, that's well supported in that. Right now, actually, we're using just nominatum. So I'd like to think about using overpass to do this rather than nominatum. It's a little more powerful, I think. We want to be able to read a secondary description and perhaps other information so that if you click on the Founders Library once, it'll say the name. If you click on it again, it'll give you some extended information about it. I'll probably do that one because I think it's going to be a little trickier. These are, the first two are a little bit easier as kind of one-offs, right? You can sort of just code up your own little piece based on what we've done already. We need to generate a very, very nice map that we can use to demo. What I'm envisioning is our LiDAR tile, or our photogrammetry tiles, or our model at 1 to 2400 scale. Ideally, the tiles matching those pretty precisely. Related to that, if somebody can pull out the corners of one of those, the latitude and longitude of the top, bottom, left, and right of any one of those tiles, and then the same coordinates in UTM 16, right? That's where we are. And then someday a web interface. So where I see this going in the future is not a Python app that runs on a laptop, but a service that's essentially on the back end of a website, right? So the website captures the video, and it does all of this behind the scenes. So nobody needs any special equipment. Nobody needs to install anything. They just go to, awesomemaps.com, and it does it all for them, right? They just need a camera. Otherwise, there's nothing else they need, right? They should be able to print out any map with any QR code, and it should work. So then we would just need to figure out how to capture camera data and type it into a Python function, but that's already, again, established technology. Goals. I'm hoping to finish this DeKalb trees project, and I still haven't done any flight times for the Maker Beam drone, so hopefully that's been sitting around for a couple of weeks. But it does fly. Okay, just I don't know how long. The main thing that we need to do, we need to get. Those are some of the goals. We just talked about that. I need to get ready for the URAD stuff, so I need to order a URAD drone. I'm thinking about getting a Mavic Pro. You guys seem super satisfied with it. So what is it, $1,000?
With attachments, yeah.
Okay.
I think we ordered ours for about a little over 800 each. Then we throw in another battery.
Batteries are like 100 each?
80 to 100, yeah.
Okay. Yeah, I'm thinking about getting that, a pile of batteries, call it good. I'm still a little unsure about whether I want to try a fixed wing drone operation, but I feel like a half-hour flight time is pretty good. I mean,
Depends how much area you need to scan.
yeah. I was looking at the maps. Mel showed me the maps, and it seems like it's pretty dense forest down there, so I don't know how well the photogrammetry is going to work in those areas. I didn't think I appreciated how dense the vegetation is. So I'm thinking about refocusing the problem on sort of like coastal areas where the density isn't so bad.
Well, that'll tie into my presentation later.
Great. Okay. And then finish the research poster, which I'm sure Matt will talk about. So that's it for me. Sammy, you're up. No, here we go.
All right, this is my lab report. Oh, wait. I uploaded the wrong date. Let's see in 1 second. No, okay, so now I just copied the tile from there. So, okay. Yay!
Got to the right file? Wait,
No, it's the right file, just the wrong
okay.
title screen.
Oh, gotcha.
Title screen.
Okay.
Okay, last week goals, LAS, I guess, but I was trying to collect some field data tests, run preliminary tests on some of the data, finish installing Windows 10, and fix GPU. Those were my big to-dos this week, or hope to-dos. For field data, that I've actually been going full throttle on. I've actually managed to get in 3 flight sessions this week. Well, since last live session, since last time we talked. This is my area of interest for the first section. There's a whole other section, but I'm just trying to get some stuff in so I can start running some tests just to see if it's going anywhere. I've gridded this section out. This is the Knolls subdivision over south of the train tracks and west of Annie Glidden. It is a newer subdivision, so the trees are younger trees, but they're not as crowded, so they're should be easier to actually identify where they are in relation. And as you can see, Dustin's points are much easier to track than some of the ones in the other section, so I figured that would be the best place to start. I wanted to try and get them in the leaf off condition, just so we can have some comparison with leaf on later, so that's why I've been really rolling fast. So far, I've gathered about 2,500 images from that section. I'm averaging about 500 a flight, or 500 a tile, and I've been doing the tiles in 300 by 300 meter squares, which is a nice little chunk.
Is it 2,500 images from each tile?
No, it's just total. Each image is getting about 500 images. I'm running the double grid patterns, so it goes back and forth one way, then back and forth the other way.
Okay.
And depending on the wind, I'm getting right there at the end of my battery life. Each one takes about close to 18 to 20 minutes, depending on the wind.
Okay.
So, yeah. I did actually try. I tried one the other day to go out there. It was a little too windy, and actually had to go chase my drone down. I had to stick it in hover and actually drive to where it was. So, but it worked. I stuck it in hover and drove to where it was because it was not coming back to me.
Too windy.
Too windy.
What was the wind speed that day? Do you
It
remember?
was like 20 miles an hour. So I did go out yesterday. I did go out yesterday. It was a little breezier, about 5 to 10 miles an hour wind. It made it. The battery was getting right. It was really pushing my limits on the battery, so it was going about 30 kilometers an hour one way, and then about 10 or 12 coming back. So it sort of balanced out. Okay, so that's what's going on with the field data. Some of the
How
cool.
high are you flying?
I'm flying at 80 meters. I've been actually running about a 80% overlap. It's probably going to be overkill once we get going, but
Why'd you pick that height?
it seemed to be
It's significantly below the ceiling, right? So that's about 250
it's low
feet.
ceiling, and because I have seen some planes flying fairly low around this area.
Right.
And with Pix4D, when I'm flying, it actually, if it's set too low, it gives you a warning notification saying, basically gives you a yellow screen saying, hey, you might want to raise it up. And so I was raising it up until it did not say that, and then it's nice.
Okay. I wonder. I mean, if you prioritize finishing your thing, but if you are you going to try to do that? I don't want to jump ahead in your presentation. Are you going to fly the old neighborhood too?
Yeah.
Okay.
Plan to try and get them all.
Maybe it might be worth. So the higher you fly, the more coverage you can get in less time, right? So if you feel like this is working, then I would say don't fix it. But I don't know, the other area, is that similarly sized? I'm trying to remember.
It's a little bit bigger, but it's more awkward.
Here. Got it. Handily on the cover of this. Okay. And you've got it's a nice looking red, this color. Yeah. So you're getting this section of the Knolls. What about this section here?
No, that's right now. The only thing I have left is this little strip there, and then that section of the Knolls over there. which I should be able to get in just maybe 1.5 flights, because
This is,
okay, so this is the section.
you've got 5 done. Okay. So you need.
No, I did 5 more. I already had 2 done. So I have this whole section completed. They're just not loaded up yet.
Oh, okay.
I
You
had
got this
2
whole section?
Yep, this whole section.
What about this?
This is the only point I have not done in this portion here.
And then this part, though, is on the.
That's over here.
Is in the
Here.
study area.
That's in this section here, which that's like 1 flight per game.
Okay.
That section there, and that's where the break is between the one section and the section.
Gotcha. Okay. All right, sweet.
Hopefully, if it's not too bad, that will be completely done today. So I've been trying to do a little bit of testing on it. I think there's some settings I might want to change in Pix4D, because yeah, I'm going to rerun some of these, and I want to actually, you can actually output in the LAS format too. And so I was going to try and run some of those to see how that works well, because then I can actually try and maybe use some LAS tools and things like that.
You should definitely output it. Yeah.
So that was one of the things that I
Yeah.
want to rerun it.
Yeah, I think the point cloud is going to be more valuable to you than the model.
So I plan to rerun some of those.
Cool. Are you
But
going to be able to finish? So your timeline for your course project, how are you doing on that? 'Cause I know that that's also a concern.
I think I should. That's why I'm pushing ahead so
Okay.
robustly to try and get something in there, because I have talked to Dr. Kremnick, and he knows that we've been redoing the whole thing, and so
Do you have any comments on that?
he's like, okay, hopefully it won't last all summer.
Very anti-Kremnick thing to say.
Yeah.
Right.
So I think as long as I can get it to him reasonably close to the end of the semester, he's fine. He understands. I talked to him about that.
Okay. Yeah, I would say we should be able to do the data. And in fact, I think it's probably a good idea to do the data processing of this, prioritizing that over flying the old neighborhood, because if you're going to get a result, like you're going to get a result, like it's going to be. So anyway.
Yeah. Where was I? Wasn't talking about. Lost my train of thought here. Okay, so yeah, I do want to. I was looking at the raster image that's coming out, and I think that I could have some more interesting things actually getting them out as LAS. I do have the point cloud. I just want to see how they compare. There's a difference between the LAS output and the just general point clouds.
Wait. So you're outputting them in which format now?
I'm putting them in the general cloud compare format. It is it a LAS? I got it right here.
Live compare.
Just point. I think it's just XYZ points. I think that's what it's putting out as.
So you send them in a Pix4D. Don't you record them as LAS files when you're done?
Let's see, what does it say they are? Point clouds. Yeah, they are LAS. Okay, so yeah,
Coming
that's
straight out of Pix4D.
they're coming straight. What was I gonna? Yeah, so
There's a checkbox in there, by the way. I can't quite see that from here, but to have it print out as a single LAS file.
yeah,
I tend to try to do that just because for
That's-
convenience sake.
that's what I'm saying. Because it said it can merge all the tiles in a single LAS.
Yes. Okay.
So I am putting them out in normal LAS, but I would want to make a nice big tile.
Okay.
That's what I meant with that one.
All right. Gotcha.
Okay. So that's how this is going. On that, it's been some nice flying days. If anybody wants to come out and join me sometime, it's fun. I stand around and people come up and talk to me half the time, like, what are you doing?
You should get some flight experience. I would like some.
Yeah. But once again, like we were talking about with the Mavic and the Pix4D controller interface with it, they are working really, really well. I did have a little bit of delay the other day because for some reason Pix4D kept saying it could not connect or would not allow me to initialize the flight. Turned out there was just too much junk on the phone that I was using, so I basically wiped everything out on the phone. I'm just using it as a blank controller. So that's working much better now. Okay, server. As you all have seen, the wonderful offset image on that. There is some BIOS settings that I need to change, and that people said you can try and help me do that. I was really hesitant about doing that because I did not want to wind up having a server with no screen. Because I'm not quite familiar with that. The Windows install package is on the machine. I just haven't wanted to run it yet because we've been processing stuff pretty much all week long on it. Didn't know if that would interfere with it.
Yeah.
But that is ready to go. Just needs to be launched. And I'm not doing it as a virtual machine, as I had thought I was going to do, but actually as a separate partition, I guess. So that's working well. 360 camera rig. I have it set up and ready for testing. I'd like to go out and start doing some walk-arounds, do an internal and an external test. I did look at a Pixworthy paper that they put out. It's basically a white paper that they did a castle in France, and they completely modeled it to an unbelievable resolution.
Really?
I did not present on this week, so I had enough, but we'll talk about that next week.
Sweet. Yeah, I'm looking forward to
So,
seeing
in this white paper, they modeled the inside and the outside of the castle to a unbelievable resolution. They used, I'll talk about that in a second.
Okay.
I'm getting myself, so that made me really want to get that going. I've got them set to take pictures every second as I walk, so I'm really ready to go for that. Mapping for the blind. I have been trying to get the tiles printed out for you guys. We have noticed there are some missing features on the OSM that I would like to work on. Like parking garage is missing. Some of the features over in like the sports complex. I'm going to try and look at the actual settings of things.
You want to make comments?
Yeah, so some of the things that we're noticing, parking garage missing, the fields, they're in OSM, but we have to figure out why they don't present inside the stadium. Really weird details of the parking lots. Not quite sure why.
Depends how they're tagged.
Yeah.
Yeah.
So
when you what you can do is just kind of go through JOSM and inspect the tags and see if you can kind of figure out why that's printing the way it's printing. Kind of reverse engineer their method a little bit to figure it out. I don't really mind these. I mean, it's kind of obnoxious, but better than a missing building. I think so. Yeah.
But it's like they're not consistent. Like these are parking here, these are here, but they're not printing here. Although, as you saw on the model, they are tagged. So when you scan them, it was pulling up the parking.
I think it would be better. I agree with Earle. I think it would be better if they were more like that than this. But this is pretty obnoxious. So.
But that's just one of those things I've been able to throw on and do some other stuff. So that is going.
Oh, we need to order more warm white. Because I don't think I ordered. I think that's all cool white. Everyone else is the same. Yeah. You know what's pretty neat is the spool. This printing these takes almost no filament. I mean, that is really efficient. Way more efficient than our stuff. So that's interesting. Like, however this is coming together, I feel like part of it is the thickness of the tile, which is a little floppy, but not bad. It's glued down. Seems fine. So I may want to kind of, take a couple of pages out of this book and reduce the thickness of that.
One thing I did do is I did speed up the base layer printing because I noticed no real difference.
No, it's fine. It's all right. Share those settings with the next lab thing if you think of it. So there's a good record of that.
So instead of 4.5 to 5 hours, they're only taking about 2 hours now.
Oh, that's
so
Earle's much more welcome to try that out than me. Slow and steady for me.
So, okay, that gets us into one of the 2 articles that I dug into this week. They're going backwards. No. Okay, this one I want to do. Okay, this one is a comparison of the 3 different orthomosaic softwares out there. It was done in 2015, so there are a couple upgrades behind, but overall I think think most of the stuff held up well with what I've seen. They tested Agisoft PhotoScan Pro, Pix4D Pro Mapper, and the Microsoft Image Composite Editor. I did not know, one thing I did not know is Agisoft is actually a Russian company.
Oh, I didn't know that either.
Yes, they are actually a Russian company.
No, hot dog.
So, nah, that was new to me. Pix4D is Swiss. I didn't know that.
I didn't know that either.
Oh, I did know.
I thought it was European. I don't know why
Yeah.
I thought.
So they are that, and then Microsoft is half the world. Okay, so getting into this, the person started with a data set. They actually started with a collection of 969 images total, but they actually parsed that down to only using 223 images for their entire scan, which it just seems like sort of a thin coverage, because they're actually covering 15.5 acres with that. So that seems to be a little thin, but you know, I haven't actually run the math on that. I want to see how many compared to what I've been doing. But so they parsed down because they said that there were things they were not happy with, either the imagery, some artifacts in the other one, the shadowing, just blurriness that they just they're not too happy with. They collected it on September 26th of 2014. It was UAV collected. They used something called a Leptron Avenger. That was airframe, and they actually collected with a Canon EOS digital DSLR camera, which I was like, well, more power to them. So they actually put a real camera rig on it. I guess that might have been.
Where was the study conducted? Do you remember?
Oh, shoot! I did not put that in there, did I? Oh, Michigan, I thought. He was from Michigan. Yeah, Rayburn Marsh Preserve near Ann Arbor, Michigan. So yeah. So okay, yeah. So the one thing was they did not use the embedded GPS EXIF imagery data. He said it was just really low accuracy on it, so wasn't comfortable using it. Thought I turned it down. Okay, so to fix that, they used ground control points. They collected a total of 70 out in the marshlands. They decided to use 53 of them, and they collected that with the Trimble TC-S3 handheld unit using R8 GNSS RTK rover. So they actually went out and did some hand collection of those. Okay.
Skip to the results.
Okay. Okay, just this the workflow really quick. Image, round 3, compared for geometric accuracy, visual accuracy, and statistical analysis. He actually identified the workflows of each one of the systems, and they do have different workflows in them, which I thought was kind of neat. Agisoft has a 4-stage workflow. It does image alignment first, dense point cloud formation, mesh creation, and then it does a texture creation on top of that. For Agisoft, these can each be run independently, though. So, and they can be run independently, and you can run them in different orders. You can,
I imagine you have to do the image alignment first.
right, but you can go back and so that it can be run so different ways. And you can also skip things, like you can go image alignment and you can go straight into mesh. So I don't know, they were saying that you can really specify what you want to do. So
Okay.
Okay. Outside of the inputs of the ground control points, there's really nothing else to do in it. But there are these different settings that you can set for it. So it does have parameter settings. So not too bad. For Pix4D, it has a 3-stage workflow. The image initial processing, point cloud desensitization. So yeah, 3 stages: initial processing, point cloud desensitization, and then the DSM orthomosaic generation. The processing options for this one, you actually have to set them up before you run the processing. So you go into your options and select all the different parameters. Just turn it down. And you're going off. Nobody I want to talk right now. Okay, that was another thing that between that and the Agisoft, they said you can change the parameters as you go along. If there's something you want to change in between each step, you can actually change those. That was one thing he did point out.
You haven't run Agisoft yourself yet,
No,
right?
I have not.
And Emily has access to that?
Yeah, Dr. Roundbacker has it on his system over there.
Before they all take off, see if you can run it once.
That's what I'm trying
Anything
to do.
once, just to sort of get a feel for how it works when you're.
That's what I
behind
was
the
trying to do. I'm talking to Mike about that, so we can try and get that going.
Okay.
So it does have settings that you can add into it. You know, of course, they all do. Now, then we get to Microsoft Image Composite Editor. It is only a panoramic image stitching, so it has very limited workflow, limited options and limited output. You import, you stitch, you crop if you want to, and then you export. Okay, now to test the geometric accuracy, used a root mean square error. They measured a bunch of points in it. They compared the X and Y of the image points compared to the difference in the XY of the ground control points. They ran a one-way stacked ANOVA because they said that it is not normally distributed, but the ANOVA works better than something like a Crystal Wallace or anything else. That was his reasoning for using that one. So for their root mean squared errors, they said Pix4D had the best one, an average of 7.7 centimeters. Photoscan had one 10.9 centimeters, which are both relatively good. You jump to ICE, though, they had a root mean square of 34.7 centimeters.
Still impressive for how fast it is. You haven't seen us run ICE yet, but ICE is the Microsoft Image Composite Editor. It's free. You just dump a bunch of photos in it. It doesn't have to be, I mean, it can be like photos you took in your backyard, like you can stitch together panoramas and stuff like that, which is, I think, what it's for.
Yeah.
But if you dump, images that you've taken with the drone, you can essentially make an orthophoto out of those.
Got a couple, I'll show you. I got a couple in my. I've actually been taking from some of these too. So.
Yeah, it's. I did my grandparents' farm that way with ice. Half a meter, or a third of a meter is actually pretty good for. It runs lightning fast. Like instead of taking hours to process, it's like 10 minutes. Like it's pretty sweet and it's free. Yeah. So it's good to know that like on a budget you could actually do okay. I mean visually it looks pretty good, but it's nice to get the numbers. Yeah, they do sometimes put in artifacts.
Yeah, there's some.
So it'll, as it's trying to match things up, it'll screw it up, and you'll get like extra pieces that aren't there, like phantom roads and like phantom features that are you totally miss. You can't unless you know the area. Right. You wouldn't be able to detect it. Have you ever seen like? Yeah, in fact, I think I have one for the drone flight that I did over by Anderson.
I've got some. I'll show you after we're done.
They're neat.
I did some of the stuff by my house, and I put them in there. And so they had a couple of roads that curved around and didn't appear in like driveways that weren't quite where they were supposed to be. But so yeah, you do get some really funky results. But
there's a webpage actually with where they have like really funny ones that like it has like stitched things in there that don't belong. I'll see if I can find it. Of course, they're really good.
Okay, so from a statistical standpoint, with a p-value of 0.05, yay, p-values. There is no real difference between Pix4D and PhotoScan, but there is a huge difference between ICE and form, not from, not form.
Yeah, I wondered how the ANOVA was working. So in ANOVA, I don't know how much stats you know that.
I'm gonna make stats right now.
Oh,
Okay.
So ANOVA, you're looking for differences in category, right? So
Yeah.
is there a difference between Class A and Class B? In this case, what they're doing, I'm sure, is looking at the RMSE of each individual ground point as a collection, and then comparing those. My beef with that approach here is that to say there's no statistical difference between the one and the other, there's a measurable difference, right?
Yes.
So what you're saying is that you can't. I'm not sure that I love the application of an ANOVA here, but
That's why
sure.
I really tried to point out your nice little p-value, p-hacking on that one.
yeah. It's. I'm sure. I mean, what that's saying, what they're trying to say there is there's no real difference between Pix4D and Photoscanner. We can't establish that the one is better than the other.
For the
I think that's probably not true, given what we've seen and all the other evidence out there.
And I think it really might need to do some updating, because I know Pix4D has jumped amazingly in the last, since we
I
started.
think that's true. Yeah, it's definitely better than it was a year ago.
And I'm not quite sure, and I haven't run Agisoft, but I don't know if they've been keeping up with just the sheer massive stuff that Pix4D's been coming out.
I'm glad that we've been on Pix4D because they really seem committed to keeping their stuff updated and state of the art. So.
And they keep calling me or sending messages to see if we want to do a live training session for a couple $1,000. Yeah. So they did run the turnkey test. The
Tukey.
I want a turkey test. That's just a test where they take the mean averages, they box plot it out, and they say, are they overlapping? It's just a way to visualize it. So the ICE and PhotoScan, there is a significant difference. And then ICE versus Pix4D, significant difference. Pix4D versus PhotoScan, they're overlapping. There's pretty much no difference according to the parameters and the tests that they run. Now, visual quality is the other thing that they did test. And this one they did a little bit differently. They used ArcGIS version 10.22 to do the generate random points. They generated 100 random points. Then they established 5-meter diameter circular buffers around each point. And they actually manually went and assigned classifications to them, whether it was reed canary grass, type marsh grass, mesic prairie, or woody vegetation. And they actually just visually went and inspected and compared what they had. So they did that the old school way. They used a binary classifier to see if each one of the images had a artifact, a blur, or something funky with the processed image. Then they ran chi-square test to calculate between the two image groups. And then they used Fisher's test, Fisher's least significant. Fisher's test of least significant mean, or LSM. Yeah. Okay. So the chi-square, they calculated between the groups. That's the test between the Pix4D and Agisoft, each one of the categories, or Pix4D and ICE.
So we're trying to figure out whether there's a difference not only between the software, but between whether land cover feature class actually has a piece.
So yeah, and then that's what they did with the Fishers. That's what they're testing the individual pieces within and seeing if there were difference in errors there.
Quick time out. I'm going to set Ben up with this exam because he's here.
Oh, okay. Okay, I'm going to try and speed a little bit quicker. Just go into things. So I won't really bother going over too many of the individual little details, but he's got P-value classes. He did a bunch of testing within the different tests that we just talked about. This one's kind of interesting. This is their artifact test. When it said he went through and did some testing on it. percent with artifacts. This one really surprised me, actually. It didn't seem right to me. I don't know. It's my usage of the other things. He was getting no artifacts with ice. I have to dig back in. I don't think he actually specified, but I really don't think he ran this because it only can do the first stage. I think these were looking at multiple secondary and tertiary stages, so no ice. So that class you shouldn't even put that in there. I think honestly, it's sort of misleading. But these were the later things. This is where it really pointed out.
Ice
Though.
is full of what I would call artifacts.
Yeah, so
Yeah.
I don't think you actually calculated, which I don't know why you even put it in there. But the difference between Pix4D and PhotoScan in artifacts was really severe. I was really surprised about that.
Many fewer in Pix4D.
A whole lot fewer. Like about a quarter of what he's getting. He's getting like 29 average per each photo set. He's getting 80s, high 80s in PhotoScan. So
Okay.
then blur. This one, he's actually getting more blur in the Pix4D imagery. So the PhotoScan is actually coming out nicer in the photo imagery. So these results were kind of interesting with me. He's actually got a lot of stuff, secondary data you can actually look up. So, okay, another thing you talked about was cost, which are a big thing for people like us. PhotoScan, cheap. And this was 2 years ago. I did not actually look up the prices, but this is about what I've heard people talking about. I think
Education rate for Pix4D is now like, I don't know, $2,000, $2,500, something like that.
Okay. So at the time he did it, they did not have that established yet. So PhotoScan, I think I talked to the guys over. Mike was saying that about $600 for the education license for PhotoScan. Pix4D, non-commercial use is $5,000. The full rate, $8,700. And then ice free. So
The monthly rate on Pix4D is pretty reasonable, I think.
350 is what they had
I
at
think
that
it
time.
still is around that. And like, if you're running a business, like that's
Yeah.
a pretty good way to like contain your costs. Like, I don't think I would drop. What is it? $5,000, $4,000?
Yeah.
It
And
takes a lot of time to make that. You know, that's years worth of doing it.
And
monthly.
one thing he alluded to, but he did not go into more detail, was that for a less expensive option, you can get one, but there are requirements. Like
I wonder if that was the proto education version or something.
yeah, so like they actually are going to review what you've done with the software during that time. So I can understand, no people using their license. Now I talked about ease of use. Ice, simplest, plain simple, plug it in, chug. PhotoScan, they do say the user interface was really clean and friendly and easy to use. You could add images throughout the workflow, which is what I was mentioning earlier. So you could actually add images into later stages. So you don't have to go back and rerun the entire first stage again, which can be kind of useful. Steps can be run independently and saved, and you can do chainable batch processing. So you can actually decide how you want it to process through and which groups you want to process through, which seems kind of interesting. Pix4D, the most complicated user interface, but it is just done at the beginning. You set it up and it'll run. Stages can be run in single steps or as in a single execution. And compared to the others, Pix4D does take a significant amount of time to run. I think it was about twice the actual time that it took PhotoScan to run the same data set. So, things to consider. Conclusion, what are you going to say? PhotoScan and Ice were easier to use. PhotoScan was the least visually accurate. Ice was the least geometrically accurate. All three canopies, I was supposed to say. All three packages had trouble with the tree canopies. He wants to attribute that to leaf movement, which led to all the artifacts in the blur. And there's no single best option. Choice must be made on users' needs, cost, and what else can you say?
Don't go out on a limb there, researcher.
Exactly. So he did do a ranking table he gave for geometric accuracy, he gave Photoscan and Pix4D a 1 first place. Ice 2 for visual quality. He gave Ice actually first place for visual quality. Then Pix4D and Photoscan. Cost, Ice.
Seems to indicate ice is the best.
Actually,
Which I don't
If you're
necessarily
just trying to-
disagree with. As
for just straight orthos, yeah, it is.
yeah, because you can always just reference it to a satellite image later, right?
Exactly.
Scan it, make it, go into ARC, plop, 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 done, right?
Yeah.
Or
And for some reason, he actually said Photoscan was easier to use than ICE, though. I don't
that
know
doesn't
why.
sound right.
I know it did not sound right to me, but maybe just
Well-
because of the amount of things you can control from the interface.
Yeah, I mean there are some weird things about ice that can happen when there's not a lot of documentation and like it's hard to. I haven't used Photoscan, so I really can't compare.
So that is that one. Now the one you sent me, which I really hope that Sammy had a chance to stay around with this, because this actually deals with a lot of the issues we've been coming up for. It's removing low noise from Rigel's Bucks 1 UAV LiDAR flown in the Philippines. It's written by Martin Isenburg. It's a tutorial on removing low noise LiDAR point clouds to low noise from LiDAR point clouds to produce high resolution DTMs. The data was gathered in the Philippines over a mangrove area on a tropical beach. So it did give you the beach area is what you did most of the processing on. So you have a nice flat surface. So it was a great test bed for his work. It was done at the Nakpan beach area near El Nido Palawan. I forget which island that's on. And they used the Rigel Lux UAV, and it was conducted by AB Surveying, which is actually a surveying company that was licensed to scan in the Philippines. He wanted to make sure.
To know if I had always heard, and I don't know that this is true, but I thought the pronunciation was Rigel. Is it Rigel would sort of make sense too. I have no idea which is
Regal.
right.
I heard it 1,000 times at the conference. Regal. It's like
Regal?
Regal.
Regal. Okay, cool. Good to know.
Like I heard it 1,000 times at the conference, but it's Regal.
Regal.
Yeah.
I love lab meetings.
Okay. Now, data set. 118 million points was his initial start. Average density was 57 last returns per meter squared. The projection was PRS92, which is a Philippines 1 projection. It is based on the Clark 1866 ellipsoid. So that was what the original data was done in. That comes into play later. That's kind of important. Okay. So the first thing was get it out of that projection.
So a little bit of background. This is a tool set called LAS Tools. It's a LiDAR processing suite that was developed by Martin Isenburg about 10 years ago. It's relatively, well, I don't know, I would have said relatively inexpensive, but I think it's like $2,000 now. It's gotten expensive. It's quite good. It's got a bunch of hooks into ARC. You can run things independently. Each thing has their own GUI. Thanks again. Sure. So what you're seeing here is the use of LAS tools on the command line. So there's a conversion that's going on. So LAS to LAS. -I is the input file. So there's a number of different pieces that are sort of going into it, and then there's an output as well. So
Yeah, there's a lot of code. The entire thing it was a text block with a code block to go along with it.
that's great.
So I actually spent a lot of time trying to redo.
This is one of the advantages, I think, of LAS tools, is that it's quite easy to publish the code of how it's done, which makes it a lot easier for you to just scoop it up and use it. So that's one of the reasons why I like LAS tools a lot. Plus, this guy Martin Isenburg is apparently a digital nomad. You've heard some of those stories?
Yeah, we were talking about him at Island F.
I've never met him. He seems like a character.
But I told you about the one guy that was creating that PDAL program.
Yeah.
He said he had run into him and was talking about him. And so, yeah, people were talking about him. He's a pretty interesting character. I think I might like to meet that guy one of these days.
He used to work at Los Alamos, and he said he had to, quote, leave under some strange circumstances.
You say digital nomad.
He doesn't live anywhere. He just travels around, and like his whole job is like selling LAS tools, and like so he wrote the software, he sells it, licenses it, writes these tutorials, and just kind of goes from place to place.
All right. Huh. You might just don't pay for it. You don't know where he'll be.
Yeah.
Last time I heard where he was going to be was Bali, but that was a year and a half ago. I think he just kind of moves around.
People kept saying that was people. I heard people talking like, "Oh, he was supposed to be at the ILF, but nobody saw him." Or people were like, "Oh no, he's coming," and no, like, no, he's not. So it was, yeah,
He's a legend.
Yeah, yes.
Correct.
it's just I kind of like that. So okay, so yeah, this is gonna be basically it's a two. Most everything is pretty much dual panel. He stated what he did, then he wrote the code out for each one of the steps. It's probably about 10 pages of steps. So it's probably 20 different steps in between. And so I'll briefly talk about that, and then the code is in there. I want to try and actually run some of this, if possible. I was trying to download the file. He actually gave the file that he used. He was given permission to use the file. It just took too long to download at home because my internet connection was really slow. Yeah. So okay. First thing I'm going to do is project it from the Philippine one to UTM WGS84 because that's just what he's familiar working with. A lot of the stuff's in that. So he used 7-parameter Helmert transformation, which is not the Affin transformation that Finn was talking about earlier. It's just another one. There's a few differences. I'm only vaguely familiar with the difference of them, but I've actually been using that in Imagine recently, the helmet transformation. And then he rescaled his data file. They were scaled to the sub-millimeter, to the quarter-millimeter scale. So he just took it from sub-millimeter scale to a centimeter scale. He reduced the data file size by 200 megs. So he's like, and for this process, he said it really did not affect anything. It was just trying to clean and thin the data.
So this is a good example of where scale, you have to be attentive to the scale that you're operating on. There's no sense in doing this at millimeter scale if your instrument isn't that precise, and if you don't need the results in that at that radical precision. So
yeah, and he was showing so they had some ridiculously small readings that just didn't make any sense. So steps, he transformed it into. Actually, he had to remove some of the associations with it into the Clark. He removed the projection. He reassigned the projection. He transformed it and output it into WGS84. And then he thinned out his data. It's okay. Sorry, I'm trying to remember my code as I go along, but we can go through. Oh, I'm supposed to be speeding up. Okay. Okay. Then once he got it into WGS84, he just wanted to do a visual inspection, so he printed it all out in LasView, and he just started looking at the files. And then he actually started noticing something, that there were gaps in the data time, the timestamps on the data. So he figured that that must have been the flight transformation, when the flight paths changed. And so he said, let's do that. The fields did not indicate it, but he did see that there were different flight paths by that. So he wanted to sort through, so he actually sorted through and found out where all the gaps were. He took those gaps and he used that to split them into individual flight lines. So he searched for any gaps in his data of over 10 seconds in the timestamp, and he sorted those into the new flight lines, and he was able to pull 11 different segments out of that.
I've never used LAS sort. Interesting.
Yeah. So then he resorted the data. He reordered it using the last sort. So he put them by their flight time. He used the GPS time code to order them, and then he sorted by the return number. So it was flight time, flight line, time, and return order. Then he sorted those into individual tiles, which is what he's going to work with a lot going forward. And he erased a bunch of the classifications that were in the actual data. So he wanted to reclassify some of the data himself.
So typically when you get a LiDAR data set, now, whoever does it, the company that you contract for will classify the data according to whether it's ground, water, building, vegetation, whatever. But that classification is all a computer algorithm. And the idea is that some of those aren't great, right? So Pix4D has an image classifier, but it's not that good. There are a lot of them out there, and none of them are that good. It's a really, really active area of research. So in this case, whatever those were, he's like, they're going to suck anyway, nuke them, and he's going to do it. Okay.
Yeah, and that's one of the key points to his whole classification scheme, or his whole processing scheme, is wiping out those classification points, as he does a lot with reclassifying later on. Now he's doing a little bit of quality check, so he wanted to check the flight overlaps, and I've never heard this one. He did use a tool called LAS overlap, and it actually checked the overlaps, and he was able to use this to visually compare where he saw some anomalies for future reference. What he did was he took the overlaps, he classified them as either being the difference in the flight lines less than 5 centimeters. He classified that as white, which is just, hey, we're okay. Things with a positive 30 overlap, above a 30 overlap, he classified as red. Negative 30 classified as blue. And then he loaded all these actually into Google Earth, and he just took a look at them and saw, did they match up? Should be the next picture. Yeah, so this is a picture of his classification scheme.
In Google Earth.
Yeah.
How does he get it into a CAML?
He processed straight into, he camel files, right?
Boundary analysis points.
Yep. The last boundary, and it actually output it straight into KML.
Okay. Yeah, I've never used LAS boundary either. He's got LAS tools is packed. I mean, there's like 50 things in there.
Yeah,
Okay, go to the next slide.
okay.
I want to get a good look at the camo.
Okay, so this is the reason why he wanted to have everything in WGS84, because that's what Google Earth is in.
Yeah.
So he classified everything that. He just directly overlaid his tiles into Google Earth to just see how the base imagery stacked up with everything.
So white is good agreement.
White is just normal, nothing major. Blue is very, very good overlap, or more than 30% overlap, or
above
30. Red is below.
One is
30.
higher than the other. Blue is one is lower, or vice versa.
Okay, gotta get this exactly right. Any difference between the absolute difference, that's the key. The absolute difference, any difference between 5 centimeters was white, so that's not even thinking about that. Anything more than a positive 30, he classified as red, which means there was a problem with it. And anything below negative 30, he classified as a blue. And these are just, he used that for some references, like things that had problems. Red areas are things he wanted to.
I think blue areas are problems too.
Yeah.
Yeah.
They're both, one way or the other, it's shifted.
Right.
It's either
Problem
shifted
high,
too
problem
much.
low.
Yeah. That's a great way to say that. Those are the areas that he identified for scrutiny. Okay. So now he wanted to, out of those tiles, he picked out the ones that he thought were really odd, and he wanted to actually take a look at them. So this is the image he put in there. He used the LAS view, which is another one of the tools, and this is just that tile number that he pulled out. And so there's clearly an issue in this file. There's a lot of just random stuff hanging out in this one. It's an open beach, so he turns above and below sand. It's a beach. It should be flat. So he did a couple steps. He changed, there's a process in here. He said that when you run this, you can actually identify features by pressing the X, and then press X again to sort through subgroups of the features, and you can change the color by pressing C. I put that in there exactly how he wrote it. I don't know how to do that. I haven't run it yet, so I just want to make sure that was in there because I think that's something I'll need to know at some point. So then, as he cycled through, he got these isolated, then he changed the color to yellow, and then he checked out the intensities. So he rotated around, he looked at some of the stuff. From that, he thinks there's some sort of geometric arrangement, so he thinks it's a waveform processing issue, just coming off the sand, and just colored by flight line, different flight lines, and so that was just on a single flight line that error was coming off, and intensity. So this is next one of the steps he did. For this one, for this tile, because those are just such extreme intensities, he's going to use that to actually isolate that feature from it. So he took those outliers and he reclassified them as a random classification. He's using 23 for his junk classifications for this one. So he went ahead and processed all those high intensity areas as his random class 23. And he said it worked well for this one, but he tried it on other tiles and it didn't work because there's different features in other tiles. So he said that it worked really well with the beach because the beach is highly reflective. It didn't work so well with some of the other tiles on that one. Okay, so now he gets into his actual low noise removal. This is his workflow to remove the points that are below the ground. He specifically said that he's only doing the below the grounds one here. There's a whole other processing needed for the above ground ones. And I'm sure that's in another article I have not found yet, but I plan to look for it. He based it on two separate observations. One, that each group of erroneous points will only be affecting a small area, and the different flight lines will have erroneous points at different areas. So they'll be clumped, and each one will have different clumps. So now he needed to process each of these tiles separately, and then he will combine them later. So to do this, what he wants to do is, for classifications later, when he stacks them back up, he will actually use the higher ground levels of each one of the data sets to be the new ground level. So if the points from the other data set are below that ground level, they do not become the ground level, and the higher ground level becomes the new ground level. So it's kind of confusing, but more of his files, and he was sorting points out for each one. Flight line. Okay, now to combine the flight lines, what he did was he chose whichever one had the ground points closest to the 75th percentile of the new data set. And that was only by a 2x2 meter area with pixels of 3 pixels or more point, or 3 or more points per pixel. So he ran basically, I guess that'd be a floating box or something over the whole file.
Okay.
So he was losing me in this processing stuff. I understood what he was talking about, but don't quite know how he did it. Okay. For non-ground vegetation points in the margins, he basically didn't really care about them, so he just wanted to filter them out because all he would know was where that sand points were. So anything that was really weird or anomalous that he thought would be vegetation, he just filtered it out, wiped it out. And so what he was left with should just be the remaining ground points. So he actually sorted those and he indexed them. So, okay, what he did to sort them, points that are 20 centimeters or more below the ground surface are reclassified into his junk bin, that 23 bin, for later removal. And so basically he gets this here. These are that image sorted back out into this image. So see, he's got a nice clean boundary layer there. Okay, now to reduce the processing future, he decided to subset some of these data points. And so he used this floating 20 centimeter by 20 centimeter grid cell again. And the lowest point, each one of those was assigned to another temporary classification. He called it classification 6. And then that was now his hard floor, basically. That would be his hard floor. So he went through and now reclassified everything and excluded all those extraneous points from his class 23 and all those lowest points from class 6. So now he's just got what he feels is his thin beach layer. Is he reading code?
No, go ahead.
Okay, and so this is what he wound up with. This is his new DTM. He says it's got 25 centimeter resolution, and it looks fairly smooth, but he did point out that there are still some anomalous features that he wasn't quite sure if they're actually ground features or if they're data features. That he said, that's when you have to actually just go in and do some more secondary. Yeah. But I think it looks pretty good.
Yeah.
It's fantastic. So, and yeah, he just viewed those in a Halaz viewer. So, okay. That was that one. Tried to squish it. Last week, labs goals. Yeah, that was supposed to be the okay, lab goals. Collect field data. That's going very well. The running preliminary test. I've started doing some comparisons. I haven't actually got any test results back on that yet. So I'm still not quite sure how I want to structure it. Finished installing Windows 10. If no one's going to use the server today, I think I'm going to go ahead and update that, and fixing the GPU, it's in progress.
Yeah, you can do that first.
Yep. For the upcoming week, I want to finish my off-leaf scans for at least that area so I can really do a good data analysis first run going in and finish the server installs. And I want to try and get out to run the 360-degree camera test, take a little walk around the area just to start processing through. And I guess we'll pass the new tiles and campus map off to you and let you reference the corner point.
Yeah.
So
the 360 cam test is probably the lowest priority there. Obviously, your scans are the highest priority.
Yeah. All right, so that's where I am, and it looks like I managed a nice hour. I did remember one of the things I forgot to put in there was the work with Jennifer Corker. I wanted to talk about her. I did do a first batch of maps for her. First batch of maps that she wanted for her presentation. I guess next week or this week. So she has some stuff to start working with. She wants to start now actually doing some data analysis in the map environment also. So that's what's going to be working on. And apparently she said she can't make Monday. Did you see the email from her?
I did, yeah. I got to respond back Tuesday.
Tuesday I'm
we'll
packed, so
we'll work it out.
Right. So okay, there's other things I just can't remember right now, but I want to get that in there and exactly what.
All right, so I'm going to give a brief 7-minute synopsis of what's going on. So the major thing was making revisions to the poster, kind of rewording a lot of the stuff that you had talked about, moving a few things around, but most of it was just kind of going through. And I'm sure as you guys read it, there are words that I glossed over again. But just kind of, I went through it, and the stuff that you had talked about in your presentation last week, just kind of tried to tweak and stuff like that.
Yeah.
And then I talked to Phil, and he'll be here over the weekend. So I mean, if you want to look at it, I guess now and then later today, make changes and stuff.
Yeah, let's hammer it out later today.
Yeah, and then if we could get it to him, tonight, then he has the weekend. He seemed perfectly comfortable with that.
Okay.
And have it done by Monday. But I think it's, I don't know, anything like standing out right now, or do you just want to talk about it later?
Yeah, we can talk about it later. We'll reformat that.
Okay.
I still kind of want to change the title. Did you
Yeah.
email about that?
Yeah, it's set in stone.
Set in stone. Yeah, that's fine.
I can change my map, just it's in the publication like that.
That's probably what I would do.
Yeah. But I think you do pretty good, so I don't think anyone's going around checking, so.
I know some people have changed theirs from the time it was submitted.
Let's just change it and
Okay, yeah. But yeah, we can go through this more later tonight.
yep, 4 o'clock.
And so then you talked about adding descriptions into OSM for not all of the buildings, but like Davis, the one that what's his name is in.
Graham.
Yeah, Graham Gable. It was most of the ones around campus here. I added like descriptions that NIU had associated with them, so that was pretty quick to get through. And then you asked me to look into the background of TouchMapper. There wasn't actually any paper about it, but I dug through this guy's Facebook kind of creepily
Ah, nice.
and his
Nice.
LinkedIn and stuff like that. Apparently he's finished. If you can't tell by the dots above the letters in his name. But his girlfriend was blind at the time, or still is. But at the time they went to like a beach or something, and he wanted her. She was talking about the environment, like she wished she could see it,
Yeah.
And so that kind of sparked him. He's a software engineer. So he pretty much just did this in his spare time.
No, that's
Right.
how some of the best things happen.
Yeah. So he just made it from scratch. I'm sure for him it was,
The thoughtfulness of the water, I think, really blows me away.
Yeah.
That was really cool.
Yeah. So I went into it, and this is like in the San Francisco Pier. So I just wanted to get like a
Oh yeah.
kind of
That's great.
complex building structures
Yeah.
with the bay. But I thought that was super cool. And I saw it over there. I didn't see the tile with the water in the lagoon yet, but I think that was super cool. So pretty much he built it around, and she was the test subject. Could she understand what was going on? If not, then he'd go back in and change it.
Yeah.
And where it stands right now is he has like a roadmap of where he wants to go with it. It still seems like he's pretty active in it. Obviously, hasn't been around super long. So he has like updates that he wants to add to it. He just recently added the stuff for like embossing paper. So that's an option on there. But it's also open source, so you can grab the code, and if there's features that you want to add to it, you can. So that's something I think to look at too.
Yeah, one of the things I wanted to do for the project of ours this week was to get it on GitHub. I've got a repository set up for it, but I haven't uploaded anything yet. So
Okay.
I want to get our stuff going in this direction,
Yeah.
in the GitHub direction.
Yeah.
So that you guys get more familiar with GitHub. It's easier to collaborate,
Yeah.
and then the project can kind of take on a life of its own later if
Right.
people want to contribute.
Sure.
Nobody ever does, but
It's there.
so,
So if you guys ever in the future, like a year from now or something, want to look at his repository, there's a link for it. And then this one up here was for, I don't think I added a picture for it because I found it last night when I was doing more digging on this stuff too. But it was this guy came up with, you type text in a box, like a website you go to, and it'll convert it to Braille, and then it outputs a 3D printer file.
ooh,
And he had like, if you go to the link here, you'll see examples of it, and it's I don't know exactly how big they are,
yeah,
but they look
we got to try
pretty
that
cool.
out.
Yeah, exactly. That's why I put it in here.
Yeah,
Because his goal, it was
That's
tied
really
into
what-
this. I can't remember exactly what link system I went through to get it, but he was using it in conjunction with like display pieces like this,
Yeah.
where you could put it next to it, so you could tell what's going on there. So I thought that was super cool and be interesting to see how that printed out.
yeah.
All right. And then you had me look at, there was an OpenStreetMap wiki page talking about some of the major things that people can do when they're editing OpenStreetMap. And so I pulled some of the major things I thought that were important from that. So when you're going through and adding features, obviously you can add, description and different attributes for it. But there's some that I think a lot of people either overlook or they just don't even know it's there. For example, I didn't know you could add the pronunciation
I didn't know that
in
either.
there, which I thought was very important for ours because, like, when I was doing the QR code stuff, if you just type DuSable into
Yeah.
it, it's not going to read it. It's going to read it, you know, like
Yeah.
Dusable or something
Yeah.
like that.
Yeah, we should be checking to see. Well, we can pull the name, but if pronunciation exists, we should be
Yeah.
using that. To do
Yeah,
that.
definitely.
Cool.
So that was a big one, and then just, you know, the little things like if it's a sidewalk, you know, is there the raised or the bumped and grooved edges at the corners of it? Is there an island in the middle of the crosswalk if it's a large intersection? Surface type, you know, that's something I think I kind of highlighted this here because, you know, that's stuff that we're already editing in you know, OSM, so why not do it?
Yep.
And so I tried to, you know, compare it to like if think about like going from, you know, your house to wherever you want to walk, to like a park or something. Think of all the points in there where you have to determine like when to stop, when to go. So when you get to a crosswalk, you know, how do you know to stop? Well, you can see, but how does someone else know? So then these are points that when you're editing in OSM, then you can consider to add attribute information to it.
Yeah.
So like the things like, you know, is it a clicking crosswalk or does it talk to you with a timer and stuff? But I think, you know, you're already in there taking the time to do it, and I don't think it takes, you know, too long to click surface type dirt or, you know, paved.
Yeah.
So might as well do it.
I saw a guy just yesterday get lost, a blind guy by McDonald's making a crosswalk, sort of like I don't know whether he was trying to cross towards NIU or towards the police station. Wandered out in the middle of the intersection after I had already gone through. So I'm like watching this happen in my rearview mirror. Fortunately, all the traffic was stopped.
Yeah.
But I mean, like he was clearly lost. Like didn't know how to get back to where he was going. Was like kind of going in circles. Hopefully, I'm sure somebody like stopped and helped him out. But yeah, it was interesting to see. I mean, I'd never seen that before.
Yeah, that's true. So that's a synopsis of that. And then this was looking into the thing that you emailed me a day or two ago.
Yeah.
An article where they were using SLAM for like firefighting robots in like a petrochemical like refinery scenario. And so he asked if we could, you know, install it. Is that stuff out there? So the one that they had focused on in their paper, the fast SLAM, I was able to get that, and this is just a demo running of it on my virtual machine. So that's all there. And then they had talked about using this G mapping.
Does FastSlam run outside of ROS?
Yeah, it was running on its own.
It runs on its own.
Yeah.
No way.
Yeah.
Okay, sweet.
I didn't do like any like, you know, putting stuff into it, getting stuff out, but no, it's not ROS.
Can it read a PCAP file?
I can look into it. I didn't get.
Even if it can't, I've got software that'll take I've got stuff that'll take the PCAPs and turn them into individual frames.
Okay.
So we can do that.
Yeah.
At the very least.
But yeah, it worked without, you know, any ROS stuff, so that was super nice, super easy install. And then the only other thing that they had used, and from what I understood in the paper, it's not necessary to this G mapping thing, which was they were using a filter on their input data with the LiDAR scans. I don't know too much about how like the best nitty-gritty of LiDAR, but they were trying to filter out some return signals. So I threw that in here too if you guys want to look at that as well.
Okay.
That one was kind of weird because it was on that Open SLAM, which is like a kind of a repository almost kind of deal. So that was on there, and the code was there for it. But like I said, I think, you know, for what we're trying to do, that doesn't necessarily apply, but we talked about it in the paper.
Yeah, let's talk pretty closely next week. I'd really, I mean, if we can getting a SLAM working reliably is really key. So if you can devote a couple of hours to
definitely
figuring out how to make anything run.
Yeah. Well, like I said, like I got this to install and do all that stuff, so that was a big problem with like cartographer and stuff.
Right.
So it's already going well.
Okay, so is it just like how does it install? Is it like an MSI? Like, is it install like an application? Is it just
yeah, I just cloned the repository, and then just it was whatever the regular make command is.
Okay.
I'd have to look at it again, but it was super. It wasn't anything like tricky or stuff like that.
Okay.
And then on their GitHub page, they have instructions for doing it as well.
Okay.
That's spelled out.
Yeah, create a video for next week and see if you can walk us through how to do it.
Sure.
Something that's more likely to be uploaded to YouTube, not in your presentation, but like here's how I did it.
Okay.
You know.
Sure. All right, and I don't know why my second column of goals from last week was the main one was the the poster, making revisions to that, and then the stuff that you had talked about throughout the week, like the article and stuff. So the goals for this week: get the poster stuff done today, get it sent to Phil to print. That'll get back to us on Monday. Wednesday, have a good URAD presentation. Everything will go well there. And then since the poster will be done, I want to start working on the Leap Motion integration into the stuff that we already have, see what I can do with that. Because I have a lot more time on my hands since this poster stuff is eating up a lot of it. Kind of, yeah. Continue writing the final SEF report that's due in May. And then if there's any refinements to this system that you want me to work on as well, I can do that too. And then the stuff that we've talked about here.
So one of the things that I'd like to do is it's to think about your presentation. You have a minute. You have 3 minutes.
It's
okay. Just to talk about your presentation. So
yeah.
Earle did his LiDAR presentation. You wore a backpack. He had a laptop kind of out in front there. I don't think that we can't do that with the vision system because there's really no way to set up the camera, things like that. I just don't think so. I don't think so. But I think what we could do is you can certainly have one of these with you. So you could have the pen friend, and you can have that one. That all is going to work at the time. And then what you can do is sort of have the laser pointer and talk about that and sort of say, either with a different map or with that map. The thing that I don't like about, I think maybe using the QR code is a little bit better, because the pen friend thing wasn't really our idea.
Yeah.
It's not really interesting.
Right.
But the QR code is our idea, and sort of gets at the sort of camera-based recognition system.
Right.
And then you can bring a laser pointer and kind of show that.
Okay.
Thoughts, Earle? Earle really wants a full on.
I think
I'll see if I can clear a stage first.
If we had
No,
a table, we could set it
just
up.
on the tripod. Just make a little clip, mount the piece under that. Just let them have a pointer and point at things. Just
Okay.
use
Okay.
the tripod
All right.
set up on the couch. We'll just make a little thing here. Just have it set up here. Just stick that in front. We have a little lab computer.
Yeah.
Just have it. There you go.
What about the ambient light?
Yeah.
We need to test it here, but I think lighting in there is not as intense as it is in here. It's that large overhaul hall lighting.
I think it's 10 hours of work to get that set up. It is really cool. I had another idea, which was to just have like a recorded session of that and have a tablet that you could then show. I know that's not as cool, but
He brings that. He's a finalist.
I just think about it for a couple of hours.
Yeah.
You're right.
They have
Setting it up on a tripod is not too bad.
When you went, were you there the whole time? Because
Yeah, I was.
they have it divided into sessions.
I think that they generally ask you not to set that stuff up, though. Like,
They don't want, you can't bring a table or anything like that, but something like that fits in front of your poster. That's just part of your display. Because some people have whole table setups. Like Rob had the whole table setup, and then some people had like 3D printers set up.
pieces over there.
But something like that, you can pick that up and take it with you when you're done. You're not blocking anything. It's just a little tripod.
So we need something that we could attach the laptop to it.
So I just set the laptop underneath it. Because all you do is have playing.
Yeah.
I've got music stands at home. Bring a music stand. You set one right there, just like la 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 la. Just
Yeah,
people
but
really
ideally, I think ideally we have like this, like that, right? So this here.
Exactly.
But it needs to be, it really needs to be foolproof, We won't win any points if it doesn't work. It's kind of like it either doesn't work or it's a case of waste, and if it's there.
It's a swing for the fences.
It is. I feel like
Maybe
we're
the
not
swing for
quite
the
there
fences,
yet.
or-
Like, we're really close. I don't know. We are really close. I don't always think about it for a little while. We don't want that happening. Yeah. There's a lot of, I think there's a lot of debugging. It works as a prototype, but
And if we get to Monday after the weekend or Tuesday, I guess it's a good idea.
Like,
able to
I want
restructure
just
how
want
I'm
the
going to
idea to
talk
be out
around
there.
it. But
Right,
right,
right.
right.
The idea to be
Yeah.
out there, Chaz.
I mean, I think in a perfect scenario, it would obviously be the best thing. But with where it stands right now, is it? How much of a
Yeah, we just got this thing working Wednesday.
right? So I'm kind of wondering if like I don't know what it's recording.
Oh. You can click